Afternoon, everyone. As I'm staying home today, still recovering from the surgery yesterday, I feel much better today. So I decided to record the second video. The first one is already shared with everyone, so make sure to read it, make sure to go over, and then feel free to reach out if you have any questions. I would like to mention that all the meetings that are scheduled for today, they're on. None of the meetings for our projects will be canceled. If you already reached out to me, and then if you have a meeting that is already scheduled, at this point, it's very difficult to work around the schedule to reschedule that. That's the main reason why the question was asked almost 10 days ago, and then everyone was asked for your available time. And as a group, you made that decision. I responded back confirming the meeting. So unless there are very extreme circumstances to reschedule a meeting, rescheduling them at this point it's going to be way too difficult because there is a total of 12 groups, and then I have worked around the schedule, around my schedule, around your schedule, and being able to successfully to schedule all of them. And if you pay attention to the time that you provided in almost every single case, I'm happy to say 100% of the scenarios, despite the one that was canceled yesterday due to my surgery, all the other scenarios, the meeting were scheduled based on the request that you provided. So I was able to work around my schedule and then be able to schedule every single meeting according to the time that all of you provided. Now, where do you find the link? Number one, the link has been shared to the person that requested, send the email request. So using that particular email, in some scenarios, emails of both members of the same group are shared. So if that's the case, the invitation went out to both members of each group. But if in case only one person reached out to me from the group and then I used your email, that person email, and make sure to go to Brightspace. What I'm going to do right now, I'm going to go ahead and then walk you through where to find things. So as I'm sharing, um, the site, I'm hoping I'm sharing no, this is not the correct one. Let me back up. So now I'm sharing the screen. There you go. So as I'm sharing the screen, where to find the links to join the meeting, you go to content, and then you go to project module, and then you have the milestone document. You have two versions. One is the Word and the other one is PDF. If you click on the PDF file, and then based on the number of the group, the links of the groups are part of the milestone document, and this is how you join the meeting. Okay, so let me stop sharing this, and then for this video, which will be shorter than the other one, I'm planning to go over topics of section 4.1. I would like to start off today so we can have a smooth transition into permutation and combination, which will be part of section 4.2 on Thursday. And as part of it, let me start off we're going to focus today on counting, questions that are related to counting numbers, and then will be a variety of topics that will allow us to see different scenarios of using the formulas to determine possibilities based on counting formulas. So let's say we have not a very big problem. So we have a small problem, a small list of possible results that can be easily counted. So therefore, in this particular case, if it is a small list of possibilities, then we do recommend to write the list in a specific order. So the reason why you do that, uh, once again, this is only applies to the scenarios when you're dealing with a small list of all possibilities. So if that's the case, you write them down. And then the target point of writing them down in certain order is to avoid scenarios of missing one of the possibilities or the scenario of repeating one of the possibilities twice. If that's the case, this is how you count and then compute the number of possibilities. So let's look at one example. Suppose that an ice cream store has 3 flavors available. The ice cream store has a vanilla flavor, has cookies and cream flavor, and the mint and chocolate chip flavor. Now the vanilla flavor, I'm gonna list it as a V flavor. The cookies and cream flavor is a C flavor, and the mint chocolate chip flavor is an M flavor. Now, we want to order 3 of them to take home in quarts. Now, a flavor can be repeated, but the order in which in which you place that doesn't matter. So you can place that order in any possible rearrangement or any possible order as long as you get 3 of them and then you take home. And these are possibilities. So one scenario, you are going to select all 3 flavors that are going to be the same. So you need to take home 3 of them in quarts. So the first possibility is going to be VVV. So you're deciding to take home only the vanilla flavor. Now the second option is you decide to take home only the cookies and cream or the C flavor. So your possibilities are in order are going to or the least is going to look like CCC. And then the third option is the mint chocolate chip flavor or the M flavor. If you decide to take that, then the possibilities will be listed as MMM. So that is one way of arranging these possibilities for placing your order that is including 3 of them to take home in quarts. Now, another possible way of rearranging them is 2 of one flavor. So let's say you are selecting vanilla, 2 vanilla, and then 1 cookie and cream. So that order is going to look like VVC. Or you select 2 vanilla and then 1 mint chocolate chip. So that order is going to look like as VVM. And then you run this particular combination, and then you have other possibilities as CCV, meaning you're selecting 2 cookies and cream flavors and then 1 vanilla flavor, or 2 CCM, 2 CC and M, which means 2 cookies and cream and 1 mint and chocolate chip. Or another combination is MMV, so you're selecting 2 mint chocolate chip and then 1 vanilla flavor, and MMC meaning 2 mint and chocolate chip and then 1 cookies and cream flavor. So 2 of one flavor, these are the possible combination. And then we have one scenario when you are going to have 1 for each flavor. And in that particular case, the order doesn't matter, but in that particular case, your possibilities are going to list it as VCM, meaning vanilla flavor, cookies and cream flavor, and mint chocolate chip flavor. So if I go ahead and then count all my possibilities, this is again a small scenario where all possibilities can be counted. Then I have 3 of them belonging to all 3 flavors are the same. Then I have 1, 2, 3, 4, 5, 6 of them with 2 of one flavor are the same. So 3 and 6, 9. And then I have only 1 where I'm selecting 1 of each flavor. So therefore, if I have to do the count, I'm looking for a count of 10 different ways to choose. What am I choosing as part of the order? 3 quarts to take home of ice cream. Now, as part of the counting rule, it's very important to learn what is known as the product rule. And then it's the product rule, in addition to some other diagram that we are going to use for the counting, it's going to be the focus of the next examples. Let's say a restaurant has a special menu with 3 appetizers 4 main courses and 2 desserts. Now, different from the previous case, when we do like a normal writing list of possibilities, we are going to use the idea of a tree diagram, which is very popular in these cases, very popular in probability, to list all possibilities of our choices. So let's start with the 3 appetizers. So notice that the dot sign is playing the role of a vertex where all the 3 branches of the 3 appetizers choices are creating the beginning of this tree diagram. So we have for all 3 choices of the appetizers, 1 branch. So 1 branch for appetizer choice 1, 1 branch for appetizer choice 2, 1 branch for appetizer choice 3. Now let's say I choose appetizer 1. Now I'm transitioning to select from the main course. I have 4 possibilities. So the 4 possibilities are going to be presented by the 4 branches of the tree in the next step. So you notice that from each dot point that represents the end of the first branch, representing the selected of the appetizer, there are four branches that are generated from each specific branch after the selection of the appetizer is fully completed. So once you select appetizer 1, then you have 4 possibilities to select your main course. And once we do this for each branch of the appetizer selection 1, and then we go through all 4 branches for each appetizer selected, then we get to the last step. Now we are about to select the dessert. Now the 4 branches that are created for the 3 appetizer selections. So we have 3 appetizer selections, then we have 4 branches for the main course. Now each one of them breaks in 2 for the selection of the dessert. So if you look at the top one, if you select appetizer 1 and then main course 1, then you have 2 possibilities to select your dessert. You can select dessert 1 or dessert 2 if I name them. So what are my all possible scenarios? The product rule is applied in this case. Even though we generate the 3, now we conclude by to get the number of choices by simply multiplying 3 choices of appetizer times 4 choices of the main course times 2 choices of desserts for a total of 24 choices all together. So 3 times 4 times 2, final for each of 3 choices for the appetizer, main course, and the dessert. There are, as I said, there are 2 branches of the dessert. So the first set of branches is for the 3 appetizers, as I explained. Then for each choice of appetizer, you have 4 choices of the main course, as indicated by the second set of branches. And finally, for each of these choices, for the appetizer and the main course, there are 2 branches, or there are branches of 2 choices of dessert for a total of 3 times 4 times 2, 24 total possible ways of selecting of your choices all together. So in general, this is how we define what is famously known as the fundamental counting principle. If M separate the different tasks that can each be done in N1, N2, N3, and M ways, respectively, then there are N1 times N2 times N3 times altogether NM ways to do all these M tasks. So how do I understand this? If M separate the tasks, so there are 3 different tasks in this case that we are working on. So we have one task is selecting an appetizer. Task number 2 is selecting from a main course. Task number 3 is selecting from the dessert. Now, our selections are going to be, so M are the 3 tasks in this case. In this menu, we have task 1 is going to be selecting from the main course. Task 2 is going to be selecting from task 1 is going to be selecting from the appetizer. Task 2 is going to be selecting from the main course. And task 3 is going to be selecting from the dessert menu. So we have 3 separated tasks playing the role of M. Now, each one of them can be done in different ways. So you have those, you have the branches that representing them, right? So N1 is the way we do the selection of the three selections of the first choice, which is from appetizer. And then 4 is the selection of the second choice. This is N2, which comes from the main course. And then 2 is the selection that, or your choice of selection that comes from the dessert. That's why N1 times N2 times N3 in our example also 3 times 4 times 2 to give us a total number, which is in this case computed, famously known by the fundamental counting principle. Let's see another example of this. Suppose that when we are buying a car, we have 5 choices of the exterior color, 3 choices for the model, 6 choices for the accessories, and 3 choices for the safety package. So your tasks in this case are going to be M equals 4. So there are 4 tasks in this particular case that you are dealing with to buy your car. So we're going to look at exterior color. That is your task number 1. Then you're going to look at the model, which is your task number 2. Then you're going to look at the accessory package, which is your task number 3. So M represents the number of tasks, which I'm specifically going over one by one. Then you have task number 4, which is the safety package. So we have choices of exterior color, choices of the model, choices of the accessory package, and choices of the safety package. 4 tasks altogether. Now, N in this fundamental counting principle tells you in how many different ways can this be separated. So task number 1, which is exterior color, can be separated in 5 choices. Task number 2, which is the model, 3 choices. Task number 3, which is the accessory package, in 6 choices. And then task number 4, which is the safety package, you have 3 choices. So therefore, if I label them, we have E for the exterior, M for the model, A for the accessory, and then S for the safety. So these are your tasks. And then now the choices are going to be 5 from E, 3 from M, 6 from A, and 3 from S. So if I multiply them all together, in order for me to make my decision, I have 270 possible ways to combine them to make my decision. Now let's look at a different example. An exam has 5 multiple choice questions, each with 4 choices, followed by 3 true and false questions. How many different ways could you answer all of the questions on this exam? So we have 5 multiple choice questions in an exam, each with 4 choices, followed by 3 questions which are true and false. So if I call Q the letter representing the questions in this exam, I have a total of 8 questions, which I'm going to call them Q1, Q2, Q3, all the way up to Q8. Why 8 altogether? Because 5 are multiple choices and 3 are true and false. And for each of them, I have 4 choices. So I have 4 choices of Q1, 4 choices of Q2, 4 choices of Q3, all the way up to Q5. So these are 4 choices of the multiple choice question section. Now remember, we have 3 additional questions at the end, Q6, Q7, and Q8, which are true and false. And these are only 2 possible outcomes because you either answer true or false. So their choices are true or false. So there are 2 choices. So I put 2 for Q6, 2 for Q7, and 2 for Q8. So what is the total number altogether? So the first 5 questions, they have 4 choices. And then the last three questions, we have two choices. The fundamental counting rule is telling us 4, the number of choices, raised to the power of the questions, times 2, which is the possibility you answer true or false, raised to the third, which is the number of the questions that are including the 2 possible outcome scenarios, for a total of 8,192 possible ways to combine them. Now let's look at another example, which is extremely popular. Suppose a computer password must consist of 8 characters, where each character can be a digit from 0 to 9. So we have a character that has the digit from 0 to 9, a lowercase letter from A to Z, or an uppercase letter from A to Z. And the first character cannot be a digit. So these are the requirements to create the password. How many possible such passwords are there? So in how many different ways we can create that? Remember, we are trying to create a password of 8 different characters, which I'm going to call it computer password C1, C2, all the way up to 8. Now, I know that the very first character that corresponds to this password that we are creating cannot be a digit. So the option of having digits included, digits from 0 to 9, which in total are 10 digits, it's not going to be an option for my first choice. The first character is going to be either a lowercase letter or an uppercase letter. Now, there are 26 lowercase letters and then 26 uppercase letters in the English alphabet. And then the very first letter of the password, or the very first character of the password, it's going to be among them. It can be either an uppercase or a lowercase, for a total of 52. So I have 52 possibilities to select the first character of the password. Now, the remaining elements of the passwords are not only including lower cases, 26 of them, upper cases, 26 of them, but they're including the digit as well, 0 to 9. So there are 10 digits. So your possibilities are going to be among 26 lower cases plus 26 upper cases plus 10 digits, a total of 62. So for the remaining of the characters of the password, you are going to have 62 all options. And then I see a typo at the end. It's supposed to be 62. Now, all I have to do in order for me to find this, so the last one is definitely not a 68. This is 62. So then how do I write this? Fundamental counting product, it's going to be multiplying all of them together. So I write it as 52 times 62, all of them. Since 62 repeats itself 7 times, the shortcut to writing the fundamental counting principle is going to be, in this case, 52 times 62 to the 7. And then when you multiply this number, you get 183,123,959,522,816. These are all possible passwords that you can create under this condition. It's a huge number of passwords that you can come up with under this condition. So that means you're creating a strong password. Now, as part of the fundamental counting rule, one element that is very common, extremely popular, is the element known as the factorial element. Now, the factorial element will become extremely popular into the permutation and combination. So in order for us to understand permutation and combinations, it's beneficial to go over the factorial notation. By definition, n, which is a positive integer, with the exclamation point next to it, exclamation point that we do not read it as an exclamation point, we read it as a factorial notation. So we simply say n factorial is equal to n times n minus 1 times n minus 2 times 3 times 2 times 1. With the agreement that 0 factorial, so number 0 with the factorial notation, automatically is equals to 1. So this definition means if I have a 6 factorial, then n is equal to 6. So therefore, the expansion, or I can expand this into a product of 6. The next number is going to be, which is representing n. The next number is n minus 1. So it's 6 minus 1, which is 5. Then n minus 2, which is 6 minus 2, that's 4. And then we got the idea. So we start with the number itself, and we go in the descending order. Descending is an order that decreases by 1. So the next number is going to be 5, then 4, then 3, then 2, then 1, and you stop at 1. Knowing that 0 factorial is not included in this descending order product, because 0 factorial indeed is equals to 1. And then if you run the 6 factorial in this form, you notice that 6 factorial notation is a very large number compared to the value of 6. Once you place the factorial notation next to 6, the number increases almost exponentially, becomes 720. So now let's look at one example where the factorial notation is going to have an impact as part of the fundamental counting principle. How many ways can the letters in the word binary be rearranged? There are 1, 2, 3, 4, 5, 6 letters in the word binary. Since we have 6 letters in the word binary, they can be arranged in 6 factorial possible different ways, and then the arrangement is going to be a total of 720. 6 times 4 times 5 times 4 times 3 times 2 times 1. In addition to the product rule, we do have the sum rule of possibilities. How the sum rule is defined. So let's M again represents the separated task that can be done in N1, N2, all the way Nm, N3, all the way Nm different ways, respectively. None of these ways is listed for more than one task, so there's no overlapping of task. Then therefore there are N1 plus N2 plus Nm ways to do one of the tasks. And this brings us to the introduction of the inclusive and exclusion principle. If there are 2 tasks and some of the ways to do this task are listed for both, then the number of ways to do one of the tasks equals the number of ways to do task 1 plus number of the ways to do task 2 minus the number of the ways they are performing the tasks together. So if we pay attention to this sum rule, this is where all these different ways, all these tasks are totally independent from one another. So therefore, there is no overlap. If there is no overlap, they're not sharing anything. They're not doing 2 tasks both together. Then the sum rule is strictly N1 plus N2 plus N3. So in this particular case, when you have one person doing one task and the other one is doing the second task, if there is no overlap, it's going to be just N1 plus N2. If you're dealing with 2, just understand this. But what is the difference in this case is there are 2 tasks of the same ways. So there is a portion that they share. Therefore, in that particular case, you're not only adding N1 and N2, which is the number of the ways you perform the task, but you're minusing, you're taking away the number of things that they do together, number of the ways they both perform these tasks. So let's look at one example to understand the inclusion and exclusion principle. So this is an exclusion principle. This is part of the inclusion principle. Now let's look at let's see the example. A bookstore has 50 books on sale, 30 hardcover books, and 17 books that are both hardcover and on sale. So now the 2 tasks in this case is there are 50 books on sale and the bookstore has 30 hardcover books on sale. But 17 of them are both hardcover and then on sale. So separating the tasks, so we have 50 books, 30 books are hardcover books, and 17 books are both hardcover and on sale. So to separate We have 50 books in the bookstore on sale. We have 30 hardcover books, and then 17 are both hardcover and on sale. So what we do in this case, we start off with the first one, the different ways for the first task. So that's 50 of them for the books on sale in the bookstore. Then we add the second task, which is 30 of them, because there are 30 hardcover books. And then we take away the part that they're together, which is 17 of those books are not only on sale, but they're hardcover as well. So therefore, the total in this case is going to be 63. And that's the end of section 1, which I thought of going over with this video recording to allow us to smoothly transition into what is going to cover in class on Thursday after you take the quiz, permutation and combination. Now look for the solutions of the study guide of quiz number 7 will be posted at some point tomorrow morning. Once I get access, go back to work, and then I get access to the scanner, then I will add the file in the Brightspace as I've done it in the past with all other solutions of the previous quizzes. Okay, thank you everyone. And then if you are in the group that is scheduled to see me today, again, go to the milestone and then get access to the link. It's very well designed to allow you to join the meeting. Okay, looking forward to the meetings. Goodbye.